All right. Serving a single web application to every browser is a little bit like Inspector Gadget hunting down mad agents. There's a lot of them, although there are some usual suspects. There's one that's particularly bad news. They could be anywhere in the world, and they're often in disguise. We've developed a few techniques to deal with the situation over the years, and those mainly center around three kinds of detection: resolution detection, device detection, and feature detection. Early on in the aughts, we were doing work around some evil hybrid of device detection and resolution detection. I remember back in 2006, I was working at Fisher-Price, and I built a brand site, like you do, and I made a handheld style sheet for it, because that was really cool in 2006. And so, you know, it looked really nice. I had a project manager say, "What are you doing? Why are you spending all this time? It's not like moms are going to be sitting in their SUVs at soccer practice looking at websites on their phone," which just goes to show how hard it is to predict the future. So it looked really nice. It had colored borders and little like pixel backgrounds, and it had full-width images and kind of fit the form factor that I was testing on pretty well, but it performed really badly. It was really slow. And the reason it was slow is because I was taking this full desktop website that was really probably too big for most browsers of the day. It had unminified script in the head, because it was 2006. It had prototype and scriptaculous, again, because it was 2006. It also had MooFX, because 2 animation libraries is better than 1. That was actually before MooTools for anyone who's younger in the crowd. And so it performed really badly because I was taking all this code and I was sending it down to a Palm Pilot. And the devices that we were using at that time for handhelds were utterly incapable of handling the amount of code of a desktop website. And so it's funny to laugh at how naive we were in 2006, but we're honestly still doing some of this today. I'm sure we've all been to sites that just hang in a web view in iOS. Or we go to read a blog article or a newspaper article, and you know, we're really wanting the context of the headline to read before we start reading the article, but the headline hasn't come down yet because we're waiting on a web font, and it hasn't loaded. So there's just this expanse of white space at the top. So we're still making the same mistakes today. Resolution alone is not going to save us, given the bulk of code that we're sending down. We've also done work around device detection, and device detection, one of the things that we've done is that we've said, hey, you over here, you're on a phone, so we're going to send you to the MDOT site, and you over here, you're on a tablet, and so we're going to send you to this tablet website, and you over here, you're on a desktop machine, and we're going to send you to the site that we actually invest all of our time and energy and money and developer resources on. And so we do that, but in that case, we're really forking our code base. We're creating different stacks, and trying to maintain feature parity across those different stacks becomes very difficult organizationally. I shouldn't give an example from my own doorstep, but the Guild mobile web application still doesn't have search, and it doesn't have search because Mr. Wunsch built search on the desktop website a year and a half ago, but mobile didn't have the resources to build search. So having these multiple stacks becomes very difficult. And we also do feature detection. And feature detection is good as far as it goes, but in some ways it's a drop in the bucket. We can address things at a very granular level, but we're not actually solving our larger problems. So what I'm going to talk about today is I'm going to talk about not doing mobile or resolution first or feature first or device first, but doing all of the above, putting them all together, and not making the mistake that I made in 2006, which was assuming that a handheld device meant a narrow screen, but addressing each of these types of detection on their own merits. And when we do that, we find that we're then able to create a three-dimensional matrix of space in which we can find all of our users and browsers and devices. So if we imagine resolution detection on the x-axis, device detection on the y-axis, and feature detection on the z-axis. I'm going to start by talking about resolution. I totally forgot to bring my bottle of water up here. I really need that. I'm sorry. Thanks. Sorry about that. I'm going to start by talking about resolution. So customers have a lot of resolutions, and so we have everywhere from a few hundred pixels up to several thousand. And so there are companies that are really able to pull off very fluid M and percentage-based designs. Gilt Group isn't necessarily one where that's a very good fit. If you aren't familiar with Gilt, we are a high-end flash sales site. So we run basically online sample sales of high-end designer overstock merchandise. Sales generally run for 36 hours or so. So our customer base is fairly affluent and really has come to appreciate the beauty and the high-end shopping experience. And we also have brands that are choosing to sell with us because they don't want to sell at TJ Maxx. They're trying to maintain the quality of their brand. So it's really important for us to have high-quality graphic design. And so for us, we found that breakpoints were really the best way to do that. I'm just going to talk about a few tips when using breakpoints. This really didn't work for us. Responsive design didn't work for us until we started getting buy-in across the entire workflow. It's really important that user experience designers have their Illustrator templates with guides in there, and that your graphic designers have their Photoshop documents with guides. We started actually asking them to deliver us 4 different sizes of designs. And when we started doing that, and they started responding, then we were really able to start working in this way. It's also important with breakpoints to name them what they actually are. I've seen .tablet refer to fixed pixel widths and .mobile refer to fixed pixel widths. Again, we're not making assumptions about device here. We're actually addressing resolution on its own merit. For us, we have wide, which is 1024 and above. That corresponds to most desktop browsers and the iPad in landscape. We have medium, which is 768 to 1023. That corresponds to a portrait iPad. And we have narrow, which is 480 to 767, and tiny, which is below 480. So you'll notice we're designing to Apple devices, and that's because we have customers that tend to be on the high-end side, and we want to have sort of the ideal experience that we're designing for. But we're also designing to the low end of each pixel range. And so when we do that, then we're able in development to fill in the gaps, whether that's gutters or pulling things off to the side, or using percentages in individual containers to make things larger. And so we have less variables that refer to these sizes so that engineers then can complete the workflow. So this is great. We've got breakpoints, but IE 7 and 8 don't like your breakpoints. And talk to me on the boat if you want to talk about IE 7. It's interesting, but I'm not going to talk about it now. And so we can use polyfills to have IE 7 and 8 play along. And we've been using Respond.js, and we found it to be a really good polyfill for media queries. And the reason it's good is because it's not trying to do too much. Respond.js just does the bare minimum. You'll find projects out there that claim to have full support for media queries. I'm a little concerned about IE 7 trying to use JavaScript to provide full support for media queries. So Respond is great because all we need to do is have a sane layout that looks like our site for these browsers. The way it does it is interesting because IE 7 and 8 drop the media queries from the DOM that they build from the CSS file, and that makes sense because they don't know what to do with it. So Respond.js actually loads as text only. And so it makes an additional request for the style sheet. It loads it as text, it string parses it, and then it applies the styles with JavaScript. So for using that, then you obviously have cross-origin concerns because the browser is not going to let you actually load it as CSS. So you have to load it as text only. For us, that means actually using conditional comments to load from origin. There's an HTML proxy you can also use if you have only one CDN that you're loading your CSS from. So for us, we have a conditional comment. We load from origin for IE 7 and 8. We load from the CDN for everyone else. We're also starting to use picture fill. Picture fill 2.0 came out this week. Really excited about this. We've got this on stage, but not in production yet. So polyfills are great, but we also, in addition to giving customers a good experience, we want to give ourselves a good experience as engineers. And with CSS, what's really painful is not only repeating yourself, because that's not that painful, it's just copy-paste, but what's really painful is having to override styles that you've already written. And so preprocessors really help you with this. They don't help you in that they let you nest styles. And I'm sure, like, when we all see Less and Sass at first, we're like, yay, nesting, it's really fun. But then before you know it, you've written sort of 8 selectors deep, and you've got something that's really a mess if you ever have to override it. So nesting, to me, is somewhat of an anti-pattern. Nest one or two deep, but don't end up building selectors that are really difficult to deal with. But where preprocessors really help us is with mix-ins. When you have a good design that is responsive, you have a shared set of graphical ideas throughout the full range of the design. Every time you get to a breakpoint, you're going to lose a few things and you're going to pick up a few things graphically, but you're going to have the same ideas in multiple breakpoints. And so to accomplish that, you can either copy and paste, repeat yourself, or you can declare those things outside of the media queries, and then at some point you're going to have to override them later on. And overriding's only gotten more painful as we use before and after pseudo elements and things, because then you have to zero those things out every time you want to override them. So mix-ins save you from all that, and they let you declare these ideas as sort of modular bricks that you can then insert into your media queries only where you need them and not where you don't need them. An example, I'll show a couple shots of our navigation, which we just recently released. And an example of that is a cart button. So we have a cart with a number in it, and that's an atomic element. And then we can mix that into either an icon for smaller widths or a button for larger widths. And then we mix those things into the media queries themselves. And so what that looks like is this. We have a search box or a search thing, and the interaction for that is sort of like an iOS-style search interaction. You tap it, and you get a search box underneath. And so we mix that into the narrow view as well. We've also added a button for the cart. We mix it into the medium view as well. We've also added your loyalty status. And then when we get to the wide view, we don't have to override that search style. We just create a new search style for the actual search box that we show on the wide view. And so in doing that, we've now created points on this resolution line. We've got customers bucketed into one of 4 breakpoint ranges. So I want to talk about device detection next. And device detection is something that's gotten a really bad rap in the front-end progressive standards-based community over the years. And really, it's for good reason. It's because of the things that we were doing back in 2006 and are still doing now, which is making assumptions about things that we have no business making based on the device. And because of that, we've sort of just thrown out device detection. And I actually think that instead of that, we really need to sort of deconstruct device detection and then reassemble it into something that is useful to us. So if device detection is something that is perpendicular to resolution, and it's perpendicular to features, it's our y-axis, for me what device detection really becomes about is power. It becomes about what can this device handle? How much code can I send down to this device? What can I ask it to execute without it becoming a bad experience for the customer? And so if device detection is about power, it's not really that helpful yet because there's a lot of devices out there. So what I really find myself needing is I find myself needing breakpoints for my devices. I want what I had with CSS, where I can say, for this class of devices, I want it to behave this way, and for this class of devices, I want it to behave another way. And so we made breakpoints for devices at Gilt, and we call them target experiences. We chose to have 3 target experiences, and the first is minimal. Minimal is, and these are labels. These are labels basically that are assigned to a request when the request comes in. And so minimal is the baseline. Minimal should be able to, you should be able to buy something. That's the baseline. You're going to have a fair amount of functionality, but you're not going to have 100% of the functionality of the site. And we send that to lesser powered devices that we're aware of, mainly phones. And we send that to IE7, which is a lesser powered device that we know about. And we also send it to devices that we don't know. If we can't identify you, we're not going to take the risk of sending you to a higher level experience that you may not be able to handle. And then we have the intermediate experience, and that's what we send to middle of the road devices. They're more powerful than the baseline, but they're not full desktop browsers. That's mainly tablet. I think that we're going to send IE8 there as well. It can definitely do more than IE7, but it's probably time for it to drop down from the full support. And then we have the full target experience, and that's your full desktop browsers. And so that's all very hand-wavy, but what does it actually look like in practice? Well, if it's about power, then it's about what we send down to browsers. And what we send browsers is HTML, images, CSS, JavaScript. I'm not going to talk about images here because we can actually do that with resolution detection and picture fill. So I'm going to talk about HTML, CSS, and JS. So with HTML, this becomes very easy. Basically, we have a document, and the document is large, and we want to exclude parts of that document from weaker-powered browsers. In the case of the navigation that I was showing, for us, that's the drop-downs that are in the nav. So the nav is pretty simple, but each of those stores that we list has a drop-down, and that drop-down has 3 columns. There's a lot of sales, there's blog posts, there's all sorts of things. All that content's accessible in another way. We don't need to send that code down the wire. The minimal experience doesn't need it. So we can just wrap that, and we can exclude that from going down the wire. So that's pretty straightforward. And when we do that with the navigation, with the drop-downs and a couple other small things, we find that the rendered view source for the navigation went from 700 lines down to 200 lines. Granted, some of that's white space, but it's a fairly large reduction in code going down the wire. Second, we send CSS down. And with CSS, it's kind of a pain to write anyway. And so we didn't decide that we wanted to try to do any fancy excluding of CSS from the minimal experience. We send everything down at this point. But that doesn't mean that it's useless to have target experiences available. We assign the target experience as a class name on the HTML element. And that means we can use it for styling. And we can use it to tell browsers not to do something that they might otherwise be willing to do. Sometimes a browser is all right doing something. It has technically the feature support, but the garden hose that this guy's using is just not going to work. And that can be something like expensive transforms, drop shadows, things that are expensive for a browser to render, that we might have a zippier experience in a weaker powered mobile device if the user just sees a binary show and hide rather than something that's actually trying to 3D transform itself around. So target experience is useful in that way. And finally, we send JavaScript down. And with JavaScript, it is actually a programming language, unlike CSS. And so we can actually try to make smaller bundles of JS, and we can ask the browser to do fewer things. And so we use AMD modules at Gilt, and I'm going to talk about what our expectations were, like what we set up as our use cases for JavaScript when we started this project. And so I'm going to talk about 4 hypothetical, well, they're not all hypothetical, modules. And so the first one is a simple utility. If we have something that's basically trimming white space or formatting dates or doing something that's very utilitarian, we want that to behave the same way no matter what the target experience is. These things aren't terribly expensive to do, and they have, most importantly, a very small dependency chain. So it's not that bad for us to just include this and have the same behavior in all target experiences. The second one is something that's a little more complex. If we have, say, a logger that is storing things in local storage or session storage and then shipping things off to a third-party HTTP endpoint for further analysis, that's something that may be expensive to do on a weaker device with a worse connection, and we probably don't want to do that in the minimal experience. We probably just want to let the full experience or the intermediate experience do that. So in that case, we want the module to do something. We want it to do some logging, but we don't want it to do as much stuff as actually opening up connections. The third example is something that wires up third-party code. When we use a third-party script at Gilt, most of the time, instead of dumping it directly into the page, we like to wrap it and have a module that's actually responsible for wiring it up. It gives us a little more control. And so if we have a module that's responsible for wiring up a tag container, for example, some of you might have used BrightTag, Floodlight. Any Floodlight users in the house? Well, if you're not familiar with what a tag container is, a tag container is basically a script injection framework for your marketing department. And so basically what it lets the marketing department do is have a nice, very easy, actually too easy to use dashboard, and they can just like click things and basically dump them down into the page. And sometimes those things are innocuous, like pixel GIFs or GIFs or whatever we call them now. And sometimes they're more insidious. Sometimes they're iframes with nested iframes inside, or maybe unminified scripts that also come bundled with jQuery 132. And so I have seen that before. And so it's really scary what can be put in there. And it's really important that our marketing departments be able to do marketing things because it makes us money and we sell things. But it's okay to give them the desktop browsers and to say, look, you can't do this to the mobile experience. The browsers just don't have the ability to take an extra 200K of script after page load and have the user be able to effectively interact with it. And then the last thing is something that's more like a DOM component, something that actually faces the user that they interact with. I'm going to use the example of a carousel because we recently decided that there are not enough carousels out in the world. And so we built another carousel. And really, it's pretty awesome because it's a carousel that we needed something that was very easily responsive and that had full touch support. And so we built a really cool carousel. And talk to Kevin if you want to find out about it from Guild. He made it, and it's pretty cool. So with the carousel, when we have the full experience, we have Hammer.js for touch events, we have arrows, we have lots of keeping track of page sizes, all sorts of complex things going on. And those things are fairly expensive. So we started thinking, well, what does a carousel degrade to in a minimal experience? And this is going to blow your minds, but a carousel degrades to a div with overflow scroll. Yes, it does. And it's really cheap. And all you have to do is build a div and give it overflow scroll, and all of a sudden, IE7 users can drag the little scroll bar, and that's fun. And there aren't many of them left around. And people with touch devices can just use their finger, and they can move this div around, and they can see everything is there. And all of a sudden, with almost no code, we've given a really pretty decent experience to the users of less powerful devices. And we've cut 1,000 lines of code off of their download, and we've made it faster because the browser is doing that natively. So that's what we want. So how do we get that? One thing we could do is we could have two carousels. We could make a fancy pants carousel, and we can make a slightly less fancy pants carousel, or we can make a tricked out logger and then maybe a slightly less tricked out logger. But then we have two modules, and then someone has to negotiate between those modules. If that's the implementer, then all of our web stack, all of our applications need to know how to do that. Or we could create a third module that does that negotiation, and then we've got three modules. We really only wanted one module. So that wasn't a really very satisfactory solution. So the way we did this is that we actually don't interact with REQUIREJS directly. We use require, but we have a wrapper around require. And so define and require as globals don't exist in our system. And we have create module and require modules which wrap them. And so what we were able to do is we were able to actually add a fourth argument to our define function. This is basically passing through to define. And so we can have a name, we can have a dependency list, we can have the function that returns the module, and then we can have an options object that can specify which experiences this module is wiring itself up for. And what that means is that a single module can actually provide multiple module definitions, depending on the target experience that it's executing in. And in some cases, it's going to only be one in the case of our simple utility module. And in some cases, like our carousel, it's actually going to be a couple of different target experiences. And so there's two module definitions for that. And so this is nice because when we're actually loading this at runtime, if we're lazy loading the file, which we do sometimes, it's require, it loads from the file system, we can do that. If so, then it loads the whole file, but it only registers the correct module definition. And then if we're bundling, we can actually, instead of creating one bundle, one minified concatenated JS bundle, we can actually create three bundles. And we can have a full and an intermediate and a minimal bundle. And the app can load the proper one at runtime. And that means that the minimal bundle can actually be smaller than the full bundle. So we start to reduce the size of the package that we're sending down to lower powered devices. We're only just starting to do this. We've only shaved about 15% off of the size at this point, but as we go through and as we find modules that have expensive dependency chains and as we start to make them simpler, we'll be able to reduce that even further. If we combine that with not serving web fonts to the intermediate and minimal experience, and if we combine that with not loading as much third-party code, we can very easily knock 500 to 800K off of the load. We add images into that, and we're up over 1 megabyte of savings between the full wide experience and the minimal narrow experience. So what we've done is then we've put points on this device line We've created device breakpoints called target experiences. I'm only going to talk about feature detection briefly because we all know how to do feature detection, and we're not doing anything particularly interesting here. We're just using it in a way that is only what it's designed for, and that is feature detection. So feature detection is the z-axis because it's different than the other two. We can't bucket users into groups of features. Features are granular. It's sort of their nature. But what we can do is we can use it to provide polish to our application. A great example of that is hovers. So if you just add hovers to your app, most of us have run into this at some point before. Apple is making a decision in iOS whether or not it's going to take 1 tap or 2 taps to get to the page that the link is going to, right? And Apple doesn't always decide the right thing. And it's very frustrating for customers when they have to tap things twice. So if we use Modernizer's CSS, we can simply wire up our hovers only for devices that actually support hover. We can use the JS API in Modernizer to, if we have a backbone set of view listeners, we can make 2 separate objects, one for touch devices, one for non-touch devices. And this is, of course, useful with any other numbers of features. Knock yourself out. And so what we've done then is we've created a set of points on the feature line. And so if we put all of this together, we've got a grid that, for us, is 4 by 3. For device and resolution. We've got 12 different combinations of those for our customers. But if we actually combine that with features, then we have this rich 3-dimensional matrix of space that all of our customers, all of their devices, all of their browsers can be found in. And so we're making HTML that uses only one template and switches sections on and off depending on what we need. We're writing CSS that uses mix-ins so that we can keep ourselves sane and use things only when we need them so we don't repeat ourselves, we don't override ourselves. And we're writing JS that pushes the responsibility out to the module level. It is a decentralized way of dealing with modules, so the module itself can decide how it's going to fulfill its API contract in the given target experience that it's executing in. And so it's a better experience for us, for ourselves, and we're also able to then serve the best possible customer experience to each of our members. So thank you so much for listening, and if you have questions, you can talk to me on the boat. All right.